Okay, so we just learned how to determine whether or not a relation is a function. Beyond that, you can determine whether or not it's linear. Linear means when you graph it, it's going to be a line. But you don't have to graph it to determine whether or not it's a line. It's really easy. As long as the exponents are all to the first power, it's a line. If anything's squared or cubed or to the 10th power, not a line, as a general rule. All right, so as long as your x is to the first power, your y's are to the first power, then you have a linear function. So looking at a, well, first of all, there is no y. This is in function notation, as in f of x. For all intents and purposes, this is the same as writing y. Y is the function of x in our standard graphing. But this allows you at the end to say f of 2, which means plug in 2 for x and see what happens. If we're looking at it, what power is x to? The first power, so is this linear? Yes, very linear. Yes, linear. That was the first part of the prompt. The second thing to do was to determine what's the value if f is 2. What that means is rewrite your expression, 3x plus 5, here is our x, and what do we plug in for x? 2. Plugging in a 2 here, we're left with 3 times 2 plus 5. 3 times 2 is 6 plus 5. 6 plus 5? 11, and that's the second half of your answer. So yes, it's linear, and it evaluates to 11. All right, you guys try B. Determine if it's linear, and then solve for f of negative 1.